Welcome to David Alexander Maths Tuition. This is chapter 7c on the factor theorem. So here we are in chapter 7c looking at the factor theorem. So we know how to do algebraic division. Well, hopefully we do, because that was chapter 7b. So let's just do this by algebraic division first of all. So how many x minus 3's go into x cubed plus 2x squared minus 17x plus 6. X is into x cubed is x squared times x cubed, x squared times negative 3 minus 3x squared. Do a subtraction. Be careful, this is negative, so it's plus 2 minus 3. That's going to be 5x squared minus 17x. 5x squared divided by x is 5x. 5x times x, 5x squared. 5x times negative 3 minus 15x. Another subtraction, remember minus 15 is plus 15. So that's going to be minus 2x plus 6. Minus 2x divided by x is minus 2. Minus 2 times x is minus 2x. Minus 3 times minus 2 plus 6. So we've got no remainder. So therefore x minus 3 is a factor because you can divide it without getting a remainder. Now if we're using the factor theorem, now if x minus 3 is a factor, if x take away 3 is a factor, then x equals 3 is a solution. So all I need to do is just substitute in 3 into this equation and I should get 0. So 3 cubed plus 2 lots of 3 squared minus 17 lots of 3 plus 6. So that's 3 times 3, 9, 27 plus 18 minus 51 plus 6. I mean, you might as well use the calculator for all of these irritating, probably easy just typing it in one hit, to be honest. So 27 plus 18 minus 51 plus 6 equals 0. Okay, so the factor theorem is just knowing that if this is the factor, then the solution would be 3, substitute 3 in, and as long as you get 0, then that shows that x minus 3 is a factor. Okay, so use the factor theorem to show that x minus 2 is a factor. So if x minus 2 is a factor, then that means x must equal 2. So what is 2 cubed minus 2 times by 2 squared plus 5 times 2 minus 10? Well, that's plus 10 minus 10. That will cancel each other out anyway. So we've got 2 times 2 times 2. And in fact, we can see that this is the same as 2 cubed anyway. 2 times 2 times 2 is 8 minus 2 squared, which is 4 times 2, which is 8. 8 minus 8 plus 10 minus 10 equals 0. There we go. So we know that x minus 2 is a factor, and hence factorise the expression completely. Okay, right, so if we want to factorise the expression completely, we are going to have to do some algebraic division. So we know that x minus 2 will go into this cubic expression and there'll be no remainder. So if we get a remainder, we know we've got it wrong. So x cubed minus 2x squared plus 5x take away 10, dividing that through by x minus 2, so I'm going to get an x squared, x cubed minus 2x squared. Let's do a subtraction, that is 0x cubed and also 0x squared. So now let's just divide 5x by x, so that's 5. 5 times x is 5x, and 5 times minus 5 times negative 2 is negative 10. And 5x minus 10 minus another 5x minus 10 is 0. So if I'm factorising it completely, one factor is the x minus 2, which we knew was a factor because we used the factor theorem. We also now know it's a factor because for another reason, which is by doing the polynomial division, we've got no remainder. And the other factor is x squared plus 5. Okay, so here's another thing you can do with the factor theorem is we are going to guess a solution so that we get 0. So I'm going to start, and this seems very unsatisfactory, just guessing numbers, but a good first guess would be, I don't know, let's try 1. So x equals 1. So 1 cubed plus 1 squared minus 14 times 1 minus 24. Now if I get 0, then 1 is the solution, and that would mean the factor would be x minus 1. Now 1 cubed is 1, 1 squared is 1, 1 plus 1 is 2, 2 minus 14 minus 20 is definitely not 0. Okay, so you could now try 2, then you could try, that doesn't work out either, you could try 3, but you've got access to a calculator. If I were you, I would probably just guess that x is 1, and okay, just show that you're not getting the right answer, you're not getting what you're hoping for, which is a 0. Solve it using the quadratic equation solver, except for solving a cubic equation on your calculator. So when you do the menu setup, polynomial, instead of doing polynomial degree 2 for a quadratic, do polynomial degree 3 for a cubic, and you'll see that you get 4 works, but or 4 is a solution. So show that it works. Pretend you've guessed for 4 cubed plus 4 squared minus 14 times by 4 minus 24. 4 cubed is, I should know that of course, 64. 64 plus 16 minus 14 times 4, which is 56, minus 24, and guess what? It equals 0. So 4 is a solution, so therefore the factor, if x equals 4, then x take away 4 is a factor. Okay, now we can factorize the expression completely. We know that x minus 4 is a factor, so let's divide x cubed plus x squared minus 14x minus 24 by the x minus 4. We'll get x squared, x cubed minus 4x squared, so that's 5x squared minus 14x plus 5x. 5x times x, 5x squared minus 20x. So just be careful with these negatives, so that's going to be 6x minus 24, so that's plus 6. 6 times x is 6x minus 24, good, no remainder. Okay, so there we go. X minus 4 is one factor. X squared plus 5x plus 6 is another factor. Now this is a quadratic expression that can be factorised, and that's going to be x plus 3, x plus 2. So there are 3 factors, x minus 4, x plus 3 and x plus 2. And if you go back to, if you used your calculator to work out that one of the solutions is 4, then if you keep pressing equals, you would have got another solution of negative 3 and another solution of negative 2. Okay, so I've used my calculator to solve this, and I know that I get a solution where x is 4, but I'll pretend I'm doing this correctly. So let's say if x equals 1, that's going to be 1 cubed plus 4 times 1 squared minus 17 times 1 minus 60. That does not equal 0. And then I'll just magically try my next guess, which I know is correct, which is 4. So that's going to be 64 plus 64 minus 17 times by 4, which is 68, minus 60. Well, that does equal 0. So 4 is the solution, so therefore x take away 4 is a factor. So therefore I know that I can divide this cubic expression by x minus 4. So how many x minus 4s go into x cubed plus 4x squared minus 17x minus 60. Okay, right, so that's x squared, x cubed minus 4x squared, so that's going to be 8x squared minus 17x, so that's going to be plus 8x. 8x squared minus 32x, so we need to be careful with this nasty subtraction. Minus 17 plus 32, that is 15x plus 60, so that's going to be plus 15. 15 times x is 15x, and minus 4 times by, oh, I was thinking something's gone a bit wrong here, because 15 times 4 is, that's going to be negative 60, and why have I got plus 60? Well, that's because I'm an idiot and I didn't write minus 60 when it was when I wrote plus 60. There we go. So we get a remainder of 0. So one of the factors is x minus 4. Can this quadratic expression be factorised? Yes, it can. X plus 3, x plus 5. So we can get 3 solutions. One solution we already know is 4, another one is negative 3, and another one is negative 5. So if I do a very quick sketch, the solutions are 4, negative 3 and negative 5, and hopefully we know that a positive cubic looks like this, so it's going to cut through here, down through here and up through there again. So there is my very rough sketch. That's all we need, is just label these minus 4, minus 3 and positive 4, and that will do for our sketch. We don't need to worry about y-intercepts or maximum or minimum turning points. So that's it, all done. So here's another example question, and again it's all about understanding that if x minus 3 is a factor, then 3 is a solution. So therefore we know that x cubed plus 6x squared minus bx minus 60 equals 0 when x equals 3. So what is 3 cubed plus 6 lots of 3 squared minus bx? Okay, we know x is 3, so we'll turn it into minus 3b minus 60 equals 0. So 3 squared is 27 plus 54 minus 3b minus 60 equals 0. So if I just move the minus 3b over to the other side, that's going to be plus 3b. So 27 plus 54 minus 60 is 21. So 3b is 21, therefore b is 7.